Okay, we are going to tackle something completely new now. This is the topic of indirect proofs, and I'll just tell you flat out, you're going to hate them. You're going to say, why in the world do we have to do this? This is so confusing. This is so stupid. I hate this. I know. What can I say? What I will tell you is that you don't do too many indirect proofs in the whole book. You do quite a few in chapter 4, but then we kind of revert back to the regular thing. And the second thing that I will tell you is that Fred gives you a lot of help with indirect proofs. So we're going to talk about some simple indirect proofs to get you started, but please don't be too frightened. I'm not going to turn you loose with indirect proofs. You're not going to have to become an expert. Okay, so let's talk for a second about what we have been doing. We have been doing these things called direct proofs. And if you want to think of it, direct proofs are truthful proofs. So we start with a given, and then we make a couple of true statements. True statement. Another true statement, another true statement, all with good reasons. And then we come up with our proven statement, which is also true, right? That's what we've been doing. Start with a given, make a couple of true statements, and then, of course, our proven statement has to be true. That's a direct proof. An indirect proof is like the kind of like the ugly cousin of the direct proof. An indirect proof, it starts the same. You have a given, and that's true. But then you make a false assumption. And you do this on purpose, which I know already you're wondering why in the world would I do that. But you make a false assumption. Then you make a couple of true statements. And then you realize, as you're making these true statements, you realize that two of the true statements can't coexist. They cannot both be true. It cannot be hot and cold outside. That's just not possible. So you recognize a contradiction. And so because you recognize the contradiction, now you prove that the assumption was wrong or was false. This assumption that you made up here, that's the one that you're now proving is false. Okay, I know, you're already saying to yourself, all right, she lost me like when she switched to the green marker. I know. I tell you what, let's do an example, and I bet that that'll help quite a bit. Okay, so now this is easy peasy math, right? This is not, I'm not trying to give you a hard proof to deal with. So, so here's our situation. I have this drawing for you, and I'm going to tell you that the given is that line segment AB is perpendicular to line segment CD. That's the given. And then I'm going to ask you to prove that the measure of angle 1 equals the measure of angle 2. This is angle 1, and that is angle 2. Okay, so right away you should be able to say, okay, I can see that this is going to work out. Of course the measurement of angle 1 is going to equal the measurement of angle 2. What we want to focus on is what it's going to look like in an indirect format. So we set up our statement and reason chart just as before, and we start by putting in our given just like before. Okay, so it's given that segment of angle A is perpendicular to the segment of CD. AB is perpendicular to CD. So our second step is we are going to make a bad assumption. We are going to assume that the measure of angle 1 does not equal the measure of angle 2. So what I've done is I've taken my statement that I'm trying to prove, and I'm going to prove that that's wrong, right? So I'm gonna assume that it's wrong. And the reason that I give here is that this is the beginning of an indirect proof. Okay, beginning of an indirect proof. Okay, so now I'm going to go on and I'm going to make my case using true statements, right? This is the only false statement I'm going to make. All the rest of them are going to be true. All right, so the third thing that I'm going to say, I don't know, what do I want to say? I want to say that angle 1 and angle 2 are right angles. And I will say that because of the definition of perpendicular, right? Our definition of perpendicular is that it's two lines that form right angles. Okay? So then I can say, so the measure of angle 1 equals 90 degrees, and the measure of angle 2 equals 90 degrees, right? And the reason I can say that is because that's the definition of right angles. Right? I said they were right angles. That means they have to equal 90 degrees. Okay, well, you should start to see that we now have a contradiction. We are saying up here that the measures don't equal each other, and we're saying here that they do equal each other. You got that? The measures up here we say do not equal, and then right here we say that they do equal. So our contradiction has been found. Contradiction between steps 2 and 4. So the assumption in step 2 is false. So this assumption that we made up here must not be true. Everything else was true. This is wrong. And so that's why we can now say that the measure of angle 1 equals the measure of angle 2, because we found our contradiction. Notice that I have proved my statement, and so now I am done. Okay? That is an indirect proof. I think we should do another one. Okay? I think we should do another one. So this one that we're going to do is, it has to do with parallel lines. So here we have two lines. This is, oops, can't see that at all. There we go. H and K. Okay? And I am given that H is parallel to K. What I want to prove is that H and K do not intersect. Okay, that's what I'm being asked to prove, is that H and K do not intersect. So I'm going to start by drawing my statement and reason chart. And I'm going to start with listing my given, just as before. And here we have H is parallel to K. That's the given. Alrighty. So then our second step in an indirect proof is to assume something ridiculous. So assume that H and K do intersect. So again, I took my statement that I'm trying to prove, and I said, well, let's assume that the opposite is true. Let's assume that they do intersect. And the reason for this, do you remember what we wrote before? It is the beginning of an indirect proof. Beginning of indirect proof. Okay, so that's why we would say that. Okay, so then our third statement is going to go back to being a truthful statement. Okay, so let's go back to maybe this idea of parallel, and we're going to say H and K do not intersect. And why can I say that? Well, because that's the definition of parallel. All right, that's what it means to be parallel. Parallel means you don't ever touch each other. Oh, look at you guys. There is a contradiction here, isn't there? There is. There is a contradiction between steps 2 and 3, right? Here they do intersect, here they do not intersect. Both of those statements cannot be true. So the assumption in step 2 is false. Therefore, I can say that H and K do not intersect. So as soon as I find that contradiction, I can be done. Yay! All right, I know that this is tough. I know that you were wondering why in the world would I ever need this. And I know that you don't like me very much now. But I will tell you that there is another proof, an indirect proof that's coming up. And maybe when you watch that video, you'll like me more.